right, Mr. Cassini, we're on top 4-1. That's for the people that are listening. It says, when a pilot flies a plane, is it sufficient for a pilot to know how far he needs to go in order for him to fly his route and land you safely at an airport?
Yeah.
Yeah, so just how far is good enough. So if I take a plane, I fly 312 miles, I'm guaranteed to land on an airport.
And direction.
I need direction, don't I? Okay? So I need a how far and in which direction. Both of those are numerically represented. Both of those are math. So we got to represent this and talk about a new item. This new item is called a vector. A vector is how much something is and in what direction. How much something is and in what direction. Magnitude and direction. Yes?
So Malaysia Airlines doesn't use vectors.
Pasta, ow. Let's not make fun of Malaysia Airlines. That's maybe in bad taste, dude. We'll keep going. A vector is a quantity that can be characterized by its direction and its magnitude, so how far and in which direction. The notation for vectors that you can use are a bold letter, which I don't know how to draw. So something like this is a bold letter. See, bold. Double strike letter, which sometimes looks like this, which means a U and another U right on top of it, slightly off kilter. We're not going to use either one of these notations. We're going to use this little arrow on top, meaning it's a vector. That means it has a magnitude and a direction. It has a how much and in which direction did it go. So, definition works for you. Go! Write it down. Definition works for you.
Are you serious?
Oh, you were here yesterday. You were here yesterday. So I'm wasting. Oh man, I'm having trouble here.
No, I want to go over the lesson. I wasn't really paying
Okay, good. Thank you for not paying attention.
attention.
Thank you for not paying attention.
This is rough. All right, Pilati. So I got to ask physics kids all dance questions. This is going to be great. We're going to work through these fast, I hope. Guy, what's your definition works for you?
I have SJ.
I have no idea what you're talking about. Crossing my fingers, but actually, you know what? You can go with that. That means nothing to anybody else. Well, it means nothing to one person, perhaps, but the rest of you pips, you know what he's talking about. Is that's legit? What do you got?
How far in the direction?
How far in which direction? Yeah, it's boring, but yes, we'll do with it. Okay, so an example of vector is 43 inches. 43 inches at 213 degrees. Mr. Cassini, what part of that is the magnitude? And what is the direction? 213 degrees. Now, you perhaps have taken a physics course, have you not, sir?
Yes.
And in that physics class, they argued that this is not sufficient. They would ask you to do something else with that 213 degrees. The northeast, southwest, or an up, down, something like that. We don't do that in here. Why? Because we're in math class. And so we are going to set 0 degrees as being to the right of our page, if this is our origin. And the other side, our vector side, our terminal side, is going to be measured this way from that spot. So if it's over here, it might be 120 degrees. By the way, 120 degrees this way could be the same as negative 240 degrees this way. Could be the same thing. Radio? All right. So no north, south, east, west, no nothing. It's always measured from the right. Now, by convention, we're going to treat the right as east. By convention, we're also going to treat this as to the right. Now, we may have some more conventions later on so that we have the same language for this class. Okay, flip this over. You're going to need a ruler and a protractor. You two apparently don't need rulers and protractors.
Need a ruler.
Your ruler now? All right. Ruler, protractor. You're probably better off using the small little metal one, just because these are small vectors.
Especially number 2.
Especially number 3. Okay, you two are in charge of making sure I make them say the same things that you got yesterday. Okay? All right, please measure vector number 1, 2, and 3, or is X, Y, and Z as it works, right? So X is 2 centimeters at 60 degrees, or 2 centimeters at 60 degrees. Either one's fine. Go ahead and do number 2.
Centimeters.
2 3/4 centimeters? First of all, we would never say that out loud.
3.
Second of all, that's a ways off. 3 I'll deal with. 3 centimeters?
135 degrees.
At 135 degrees. Check me. Same answer?
Yeah.
Good. All right, let's do Z. Mr. Bellotti, we have for Z.
I got 1 centimeter at negative 50 degrees.
Ooh. That's an acceptable answer. We're going to change it in just a moment, but that's an acceptable answer. What do you got, sir?
Same thing.
Okay. Now, I'm just for convention's sake going to say we want to go positive, but I'm with you. So if we were positive, you would say 310 degrees. I think the other class got 315. Am I correct? So let's go 315 just so that you guys get the same numbers when we get done doing things. 315 degrees. But you're right. I mean, plus or minus 5 degrees, as accurate as ever playing with these things, is not going to be a big deal. Okay, we're not going to worry about that too much, at least right now. All right, so here's the deal. I want to add an x vector with a y vector. An x vector with a y vector. So I have a protractor and a ruler. How am I going to add an x and a y vector? Well, what I'm going to do is I'm going to I'm going to pick a starting place on my paper. A little hash marks right there, so remember where that is. I'm going to get out my protractor. I'm going to place it right on top. I'm going to make a little mark so I know that that's 60 degrees. And then how long is it going to be for x? Mr. Cassini? 2 centimeters. So I'm going to use 20 centimeters just so you can see my drawing, because 2 centimeters is a little smidge small for us. So I'm going to go in that direction. I'm going to go 20 centimeters. There's my dash. And I'm going to go all the way to there. Wow, I went all the way there. Is that possibly right? That's not possibly right. It stops here. What am I doing? I'm losing it. Got excited about where it was. Oh, I need more room. Okay, so starting there, I'm going to go up to 20. That's right here. Okay. Now I'm going to add, so I walk the x as an ant. This is my x vector. Now I'm going to walk the y vector. Yes, sir?
If you wanted to, could you do the 60 on this way also?
No. We're always going to do 60 relative to this being 0. In this classroom, you're not talking about north, south, east, west. You're saying relative to the positive x-axis. Now, it doesn't change any of your answers you would have done back in physics, but it is interesting that we have a different notation for this. And there's a couple reasons for it. We'll get to all those later. Okay, so how do I do my y vector, sir?
You start from that point.
I go to the end of my x vector because I already walked that, right? I'm adding on to it. I need what angle?
135.
135, so I'll go out to 135, which I have right here. My pen does not want to draw, but whatever. Down it goes. And how long is it? 3 centimeters. So I'm going to go to 3 centimeters. Now the question at hand is, if this is x and y, how far have I gone in which direction total? Correct?
Yeah.
So starting from where I started to where I finish, this is the vector. We're going to call that my resultant. We indicate resultants by using a double line. Meaning that's what my result is after I've added x and y together. Now, how am I going to figure out what my answer is, sir?
Do the vector thingy with the resultant together.
How long is it?
How long is it? Oh, at what angle?
And at what angle, right?
All right.
That's it. That's all I have to do. This is 5 centimeters. I got exactly 5 centimeters. I think I got 4 yesterday. Holy mackerel. What a difference a day makes. Wow. I'm getting 5. I'm literally getting 5 today. I wonder how bad. Oh, well, I drew this one just a smidge long. Hold on. I drew that way off. Hold on. 1, 2, 3. Yeah, I should have ended it back here. Details. So this would be what my resulting vector would be. There we go. What's the length of that? That is 4. Hey, life is making sense. Again, if you got 3.5 or you got 4.5, we're probably okay. It's a matter of measurement. And then I got to find my angle, so I'm going to pick this thing. Whoa, don't turn, don't turn, don't turn.
Well, you find the angle of the one with the right?
I'm gonna come up here and find the angle from the starting point to the ending point, which looks suspiciously now like 59 degrees. My off kiltered by 1, so I got 58 degrees this time. I don't think it's what I got last time.
Is it 100?
Oh, I gotta go the other way. You're right. It'd be 100, and I'm getting 118 degrees. Whoa, how do you get 58 for?
You got 105 yesterday.
See? Oh, yeah, I'm still on the wrong vector. I'm on this one here. I think I got 112 though. So see how different it is? So I got 105 yesterday. I suspect this one's not as accurate because I had several issues. All right.
Mr. Rusty, I'm really
Yes.
confused.
What?
Wait, so when we're lining up our vector flat and we put it right
I'm not even on the thing. Hold on. Hold on. Lots of problems here. Let's start over again. Here's right where I'm supposed to be. Oh, yeah. Now I'm at 106 degrees. And I'm not 0 anymore, so that would be 1 off. So I'm 105 degrees. Suddenly I'm exactly 105 degrees. My pen blew that place. So that's good news. So I got 105.4, which is the same thing I got yesterday, which is rare. I shouldn't get the same thing. I'm trying to make a point of not getting the same thing. But now that I'm accurate, it actually is. This is 1 degree off. So I'm really going through 106, but it's tilted this way 1 degree. So that'd be 105. Good? Are we good?
Yeah.
All right, try number 2, except when number 2, we got a minus sign. What does a minus sign tell us to do? Go in the other direction. So instead of walking towards the z direction, which was this way, I'm going to walk exactly the opposite way. Same length, but exactly the opposite direction. Good? Okay. I'm going to pause this up so I can save it.